Greetings, people of the internet. I am back once again, and I'm ready to. I'm blowing my mouse. It's one of these laser ones. It's full of guff. What am I ready to do? I'm ready to trace some more lines. Last time it was tracing some lines, and it even made some blocks, and it kind of worked after some debugging. And I took away the thing that makes the blocks, and then what happened? Yeah, that was about it, I think. Pach. Yeah, so what we're going to do today, more trace line stuff, and maybe a few other things. As always, I'm taking song requests with my brand new one of these. Very nice. And my mobile phone is charging, or cell phone. Yeah, so let's do something. So last time I kind of just there was this bit of code that set whatever voxel was hit by the trace line, and just like made it solid. I took it out because this function is not well structured and kind of needs the like pathways for returning stuff put in properly, as there is two different ways the trace line can finish because it reaches the end of where you're tracing, or it can hit something, both of which I signified by pointing at the camera. Jeez. So let's have a look at the game. Yeah, then I said, oh, if it hits something, then it should set a voxel, except I didn't actually set the voxel because that's complex. Well, it's more complex than nothing. And the other thing I noticed was you could set voxels that didn't have the corresponding voxel set on the other side of a room transition, which is kind of ugly. So there should be parity between both sides of a room transition, which I think it has in the engine test. Yeah, it does. That is exactly right. Whoa. And the mouse is the opposite way around, so it should basically do that. Which is fine. All I got to do is think about how I can set a voxel. And I guess I'll just make some more functions in here. So oh, not present. How about a function that turns a reference frame position into a voxel coordinate inside that reference frame's side of the tesseract? Well, we kind of already did that. So this should be very easy. I still got that conscus. That should be conscus. Oh yeah. Probably also needs to know what world we're doing this on. Am I ever going to have more than one world? Should the world indeed just be a class? I don't know. So let's just copy up to here. So we make the room. Go to room basis. Look at the room position. Then the voxel position is that, which we just returned. Okay, we already did this. And we kind of duplicated it here. So that's a bit of duplicated code. That makes me feel bad. Ish. Anyway. And I feel like we should be able to like set a voxel and get a voxel. Now why is this in the world, not in the room? Because just like before, it might go across room boundaries. It has to have parity. Huh. What is the voxel type? It's an int. Let's make it a cell. Do a little bit, so now we're getting a cell back. I can make that into a data structure. I'll pass it as a const reference because it may well be a structure of some kind at some point. I'm going to get the same voxel in the same way. Is that sensible? Seems fine. Oh, Jennings Crivens, I'm yawning again. It does seem okay, right? Right, it's not very imaginative. Well, let's just try implementing them. It's a bit of a weird API. And of course it's got a world with some variables and a whole bunch of things that act on those variables and an init function, which definitely suggests this should be turned into a class. Because it's not like I've got functions that operate on sets of these or anything, it's straight up just you make one and you can do various things to it. But that's easy to do later. How would we do this? Well, first we want to just assert that why do I make that const? It doesn't need to be const. But this one does. Let's be careful with our consts. Oh wait, that one does need to be const. I just didn't make it const because I'm terrible. Const. There we go. Alright, it's all good. Okay. So that room Or insert room voxels inside. Pause. Yeah. Do we want to insert that? Yeah, probably for just now. How do I... Just to check this weird... This three-dimensional array thing, which I wrote very quickly. I mean, this is 2 minutes work at best. Does it have a safe getter? It does. Well, that's good. It means when I decide to remove the assert, oh, that is what happens down here. In fact, that whole function is that one down there. Yeah, if I want to remove... Assertion is a pretty strict way of doing this. I mean, if this is going to be connected up to scripts which people can then write, then it could do all sorts of silly stuff, including trying to set voxels in stupid places. And I probably want to fail nicely. I don't want to just blow everything up. And that doesn't fail nicely. That just sort of... the assert... If the assert doesn't fail, it'll just do garbage stuff. Okay, so we've got the room. We know we've got a position inside the room. We want to set that cell into the voxel. So room, voxels, XYZ, pos dot XYZ is cell. We're all done, except not quite. Oh, this is where it gets tricky. If pos the x is 0. I'm thinking a little bit. So first of all, we don't actually want to set the corners or the strict edges, by which I mean the very corner which you can't see but it's behind this corner, or these edges which you also can't see but they're behind there. Oh, you can actually go outside of this thing. Oh, you can swap your hologamy all over the place. Okay. Whatever. So this, like, corners and edges need to be fixed, as in, even if you try and set them, they definitely shouldn't set, because if you make holes there, if you turn them off, that's gonna be wrong, not a bit bad. It's not gonna be able to render correctly. Well, it is. It's gonna look weird. You can do that in the test version. I seem to remember that you weren't supposed to... Whoa, yeah, I got a trace. Crash. Huh. That's good. I told you it crashed. I told you. And the mouse is the opposite way around to my other one. Yeah, see, this is why this is weird. It actually works okay. It just looks weird. It looks like What does it look like? Stained glass, like a tinted glass. And I think, yeah, you can make it awful and unpleasant. But in general, the point is, yeah. There we go. The effect kind of needs there to be solid geometry in there as, you know, just, otherwise it looks like a house with no ground floor kind of, it just doesn't look quite right. So let's not do that. So that means we have to think again, and that is sad, but alas. So we could set any voxel inside the room, but if it's on a border, that's fine. If it's on 2 or 3 borders, that's not fine. Can't set it then, it's just fixed. So then, I'm trying to explain this, but I'm really trying to explain it to myself. Okay, so we know it's inside. X border is pos x is 0, or pos x is room size x minus room size dot x, I think, is floating point. So let's go straight into the voxels. Width. Y border, Z border. YZ, YZ. Width, height, depth. Okay. These are, I think, size T. Oh, yes, they are. And it's not actually equal to them, it's equal to minus 1. If I'm subtracting 1, I want a static casting to an int. We can do this. So if it's x, if it's on 2 or 3 borders, so if x, let's just add them together. Boole's kind of downcast to 1s and 0s, sort of. I mean, I don't think that's guaranteed by anything, but they tend to. If there's 2 borders, you just no, you can't do it. Straight up no. Because then it's going to break the 4D effect. So you just don't do it. Otherwise, yes, we can do it. So we set the cell to whatever we want. Then we need to, if it's on a border, I've actually done all these comparisons. Well, let's do them again. Compiler will sort that out. I'm sure it will. Probably. But let's just do pos x is 0. So if it's on the negative x-axis, then what do we want to do? We're going to get our own reference frame for the room, which is the room basis reference frame. Then we want to move that reference frame on the negative x-axis. And then we have a point. Oh no, this is getting super confusing. Seeing as this did work in the prototype, how did I actually do it in the prototype? Once again, plagiarizing myself in the past. Set tile type, maybe that's the function. Yeah, it just... converts it to a basis matrix. So it sets it with a reference frame. And it retains the original thing. Okay, that's actually more sensible. So what it was doing there was, so I implemented this thing that gets the voxel coordinate and does that, except the prototype doesn't actually do that, or it doesn't have any notion of what's at a voxel, what a voxel coordinate is, which is possibly a good thing. I mean, if you could just get a voxel at a location in like floating point numbers, like between -16 and +16, you don't actually care that the real voxels are from 0 to 31, from 0 to 32, or whatnot. I mean, I did work on the prototype for several years, so some of it is a bit more thought out than these streams, which are off the cuff. But let's just consider that. And okay, I've considered it. This function is going. It's now gone. Boom, that's that function. World side pos. Yeah. Cool. And in the CPP file, I'm going to say there's a set voxel raw, which is going to actually just do it with no silliness. And the set voxel is going to call that, and it's going to check if it's on an edge, and it's going to call it for the other edge. Voxel's just going to get the voxel. So yeah, there we go, to room basis. And the room pos is that. Voxel pos is that. And then it's going to be this function, blah, 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 blah. And there we go. A slightly more sturdy version of that. I still wouldn't really call it sturdy. Okay. So what's this going to do? We're going to say, hey, we're setting that voxel. So we're going to set voxel raw. Are we on the edge? Call another set voxel raw. Bit. Well, that makes more sense. What did I'm going to go back to the prototype and just keep copying it, because it used a flag, so it would set one, then it would jump to the opposite one, set that, but then the flag would stop it setting them back and forth like a yo-yo. That's fine. That's like a hack, though, for whatever reason. Well, let's just continue for now. Call through to the raw function. We'll implement that. Here's the thing to get a cell. So to set a cell is going to be pretty similar to hey, what'd you know? It was exactly the same. But that doesn't do the nice things where it's like if it's on an edge. I really feel like this should figure out if it's on an edge. And then that should deal with it. So it could convert to room, to voxel position, edge corner check, raw set, if sides, raw set on another room. But this is converting it to a voxel pos sort of makes it oh no, because we still have the original reference frame and the original position. I could just hardwire the voxels on the edges and the corners to be a special type that it won't do. So it doesn't have to check, it just tries to looks at the voxel, and if it's like a protected one, it's like, ah, you can't do it, it's protected. Nah, let's just be sensible about it. We'll use maths, the ultimate weapon. Okay, so this raw set is kind of probably nonsense. It is a copy-paste today. Okay, so we're going to the voxel position. Okay, cool. We've got a voxel position. That was easy because I copied it. My heart is full of lies. Oh, we do edge corner check. Oh, protected. And this is not checking pause, it's voxel pause that it's checking. I'm going to give myself 3 points for actually checking it against the room size. Okay, now it's cool to just set that one, but we know what it is. I think that cascade ball thing is actually not anywhere near as much of a hack as I thought it was. Okay, so now we raw set it. It's inside. Yeah, I've convinced myself that how I do it in the prototype is in fact extremely sensible. So it's going to be, there's a cascade. Yes, we will cascade it across rooms from where we first set it. See, I worked all this out for the prototype, and then it's like, oh wait, all of that effort wasn't just nonsense. It was actually the right answers for a lot of these things. It's not about doing it differently. It's about doing it at least as good. Maybe better. Oh, okay. If voxel pos x is 0, then we want to set voxel cascade on the same world with a different reference frame with a different position in the same cell, and we are not cascading. Okay. The reference frames here, I move an existing reference frame because the old one copied the reference frame every time you did a transition on it, which is actually not as good because, well, making a lot of copies and running a switch statement on every transition, which is somewhat unavoidable, but what I've done in this one is you have to explicitly cascade reference frame, cascade frame, CF, or just, you know, it's whatever, it doesn't really matter what it's called. So it's not enough just to move the reference frame. You also have to adjust the position. So let's say you're 0. Yeah, you need to add the room size. What do you add on? It depends which way you enter the room. If the room is not cube, or if it's not cube. So this is something the old one never did. The old one, the rooms had to be cubes. There was no other way to do it because it was very complicated to work out. Now I'm kind of doing it where it's like, it's a cube, right? You know, because that's good for the video games. But I kind of just back of my mind want it to leave it open, so it could be a cuboid, like a hypersurface cuboid. Now that's very tricky. So I'm thinking about how your position changes when you cross from one room to another. Whoa, you can see the brightness of MS Paint in my face. So here's one face of the Tesseract. What the hell? So let's say you exceed that face, so you go out beyond the X coordinate here, and you go to another room. So it's like you go up to 31, you're still inside. You go to 32, you're outside. But that corresponds to entering that room. So you should be 0 there, right? Because that's, you know. So in your next reference frame, you're 0. What if you're going below 0? You're 0 and you subtract 1. Well, now you're coming into this room, and you're as big as this axis on the room, which is well, if you move in that axis, you end up back in the room you were in. So, oh, it's gonna break my head. If you move in that axis, you end up back in the room you were in. So if you move on negative X, just to recap, how does the reference frame change? Side and MX. So MX gets flipped and becomes side, and side becomes MX. So it's the width of this room in the reference frame that you went into it. Oh, it's so confusing. What does that mean? So this is a bit I've not done before. This is what developing the prototype was like for so long. I moved the camera up and then I slouched. Developing this prototype for so long involved banging my head against every wall I could think of. And I got really far by doing that. Turns out you can smash through walls if you just keep chipping away at them, which I'm getting my metaphors all mixed up. But the point is, yeah, it's difficult. It's real difficult sometimes. So I want to move CF on the negative X. And pause needs to add worlds, rooms, CF side, voxels. It's not necessarily the width though. And that is, it's 100% confused about. It's not actually, it shouldn't be that much. If I check the old one, it'll be adding that -1, yeah, because it needs to also move a block. So -1, and that's only added to the X coordinate. Also, voxel pauses. Whoa. Hello. Yeah. Also, this whole line is nonsense. Don't worry about it. You're way too worried. Not cascading, we're done at that point. Right. Okay, so welcome to me just being basically confused. I've pushed myself into a corner and now I'm stuck. So we'll just keep going. I mean, I can format this more correctly. That should be vec3 of float of that. Or I don't even need to cast it to a float if I subtract 1.0 f. The problem with this wait a minute. Wait a minute. I have it in the room basis already. It should be room pause. And this shouldn't be that. This should be the room basis. Because that's what the voxel... Okay. Room reference frame. Right. Okay, yeah, that's... I'm sure all the people who watch this, who exist, and aren't just in my imagination, were probably screaming at their monitors saying, obviously, you've got it in the room basis, you should just work from that. But I didn't listen. I did not listen. Which is a strength. Sometimes persisting is good. Okay, cool. So we know that. We know negative x is going to move that room basis into the next thing. And adjusting this position. But this width is not necessarily correct. It could be depth or height, depending on how the rooms fit together. So if they were rectangular cuboides, then the so let's just draw a hypercuboid so I can get my thoughts a little clearer. So they're going to be 1, 2, 3, 4 lengths. I'm just drawing a square. Okay, let's make a big long one, like a widescreen TV. Okay, so that's the external. And the fourth dimension would be the length of these inner stemmy bits. Let's make them real short for good measure. So we draw the farthest away room. Drawing all these extra lines makes it very messy. So these little stems are the fourth. So we've got width, depth, height, and umami. So if we unfold that, what do we get? We get two rectangles. Why do I keep calling them rectangles? Two cuboids. So we've got width, height, depth, and a fourth. Is there a word? Fourth dimension, width, height, depth. Is there like oomph or something? Well, I'm going to call it oomph. So we've also got oomph. And for each 3 of these, of which there are 4 combinations, there's going to be 2 cuboids of that size, and they're all going to slot together like a jigsaw. So we've got the inner and outer ones. I'm going to draw this a little smaller. We've got the inner and outer ones, which I did like a TV sort of thing. Yeah. We've got front and back. Let's just continue it along. Let's just draw. Let's draw the standard tesseract surface net. So the other dimension is real short, so all these are... Sorry, that farting noise was because this drawing is not very good. In case that wasn't 100% obvious, I didn't think the drawing was very good, so I made flatulence noises to express myself in that regard. Okay. And then obviously, yeah, the one on top is going to also be small, because it has to fit in with all this. I really should have planned this better. But I didn't, okay. Boom. And there's another one underneath that's the same thing. And then there's the other room underneath as well. And so, okay, it looks, the standard tesseract surface net is like that, with rooms here, 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 and here. I say standard, that's just the one I'm used to. It's like a tree or a big extra dimensional crucifix or something. So if I feel this is never going to work, it's going to leak. These two are connected in my game, and these two are connected, and these two are connected, and like that and that are connected, and so on. Which is why the dimensions are constrained. Your hypercuboid still has to have, like if you've got a cuboid, a regular 3D one, it's got width, height and depth. So it defines 6 rectangles that all fit together. And because there's opposite faces are always the same, they come in pairs. But each rectangle will be made of 2 of width, height or depth. And they fit together like a jigsaw. So it's exactly the same principle in 4 dimensions. But basically this is a long-winded way of saying, hey, if you move off this side and you go onto this side, then is it the height or the width or the depth of this room? But because each room has its own reference frame and they're not all like in a very predictable way, you just... Long story short, is it width, height, or depth? I don't know. How would you find out? I almost had it when I was thinking about you've come from a side, you moved on negative x, so negative x. So I feel it's going to be something like it's going to be something like 2vec3 it's going to be something like this. And then I do have the room size. So if I think about it, it is consistent. So when you move X, it does, it stays, in the next reference frame, X is still X. Oh, but the room size is in the room, so if you get a room, I don't know if anyone's ever going to watch this stream and just be like, what is this guy babbling about? A room has its own basis reference frame, but then if you transit that to the next room, like you say, hey, if you're in this and you move this way, you'd end up in this room. But the reference frame you end up in this room is not necessarily the basis reference frame of that room. But I feel it's something like you'll get that, and then it'll be like dot that and the room size to -1. I think that's about it, with the caveat that this is probably not quite right. And I am never going to set this. I'm never going to set this up with an actual cuboid to test. So I need to really think about this. Ah, man, I didn't think I'd get caught up so badly in one little detail. But that's the breaks when you're making a... Oh, new updates are available. Start that update. Qt telemetry. No, I'll do that later. We did IDE management stuff last stream. So if you move in the negative X direction, what might really help is an example. And we've got the basis matrices. So let's say we're on the positive Z side. And our reference frame is this. And it's tiny, so let's make it... Let's make it different. Tools, view. How did, wait. No, don't do that. How are you supposed to get rid of it if you don't know? Where's the options? View. Highlight mode. Yeah. View. Side panel. Oh, I remember. It's there. Very difficult to find. Font. Yes. But I don't want it 16. Wait, no, I do. Yeah, no, that's cool. There we go. That's pretty easy to see on stream. Nice. Okay, so here's where we are. We're on this side of the tetrahedrect. Okay, so hedrach. And we're going to move negative x. Oh no! What does that mean? Our next side is going to be negative x. I don't like this example because it's too... Having x as positive x makes it too close to being trivial. Okay, let's go on the negative z side. We're on the negative z side. We're on zinc. We're going to travel in the negative x direction. Okay, so our next side is... We're going to be traveling... So if we traveled in positive x, we'd end up on negative w. So we consider the x-axis to point towards negative w. If we travel on the x-axis, we're traveling towards the negative w side. We're traveling the opposite way, and the opposite side is positive w. So after transit across tesseract, the side is now going to be positive w. And now our x-axis leads back to negative z. Negative, there we go. Our y and z axes are not changed. So in that case, it is that. That's the other one. It is this, but it's got to be... Yeah, this is correct. So why is it correct? Because negative z means it's the depth. On your x-axis, you're looking towards negative z, the room you just came from, which means you consider x of the room to be the z of the room in its basis. So is that right? Because it should, so it depends on... Oh, I've had a great idea. Comment, cuboid. This is probably wrong for a hypercuboid. I tried. There! Now we can continue. Why? Because I put a comment, so you know it's all good, right? Now, if x is the same as voxel's width, then we move CF in positive x. I feel like there's a big optimization I can make to make all this compact down. So in this case it's not actually so hard because we already know that it's room width. Yeah, that's easier. So what I noticed is this is actually cf.side before before you transit the room. This is cf.side. I'll call it test. Yeah, whatever. It's one of them. I don't care. So that can actually reduce that. Because side changes when you move the thing. Unfortunately, so I think that's the same. That should be good. You don't actually need this test unless it's... Well, there's a 50% chance you'll need it. So let's not call it test. Call it axis, because it's just like the axis you're going to dot. I don't know, I can't think of a good name for it. Unfortunately, this and this are not really the same. So ultimately I think I'm gonna have to just blast through it for X and Y and Z. And that is unfortunate, although I will have a think about how to with I'm doing this in an extremely haphazard way. This at least is agnostic. So this is like room size -1 times that to vec3. This is a totally different thing, -1 times that to vec3. I'm trying to think of, because I like to put these into a little for loop that'll just test all 6 axes, one after the other. And I know that actually it's probably nicer or whatever unrolled, but it's just ugly, verbose code that's highly repetitive is just nasty. And sometimes things are nasty, and that's fine, you know, what can you do? But you know, it would be nice if they weren't. X, Y, Z. And also, does this work? I have no idea. It might work. Oh, I've got this other slightly worse implementation hanging around. Does it build? It does. Interesting. Oh, okay, if trace t is less than 0, m world, set voxel m world as a reference frame, trace reference frame, please. What is it expected here? Position, trace position plus 0.5 times trace normal. And what we're saying to, it's saying it to 1, which is a valid cell. Very, very suspicious that this will do anything. That was a lot of cerebral activity. It did nothing, for obvious reasons. Dirty flag was never set. It's not going to rebuild anything, whether it works or not. Well, that definitely didn't work. Yep. No parity. I mean, it doesn't actually matter about the parity exactly. Because I could just make sure it's always correct, but that's a really terrible approach to computer design. Like software and computer content. You have a computer. It's good at doing repetitive, fiddly tasks, like making sure these things are always correct. That's not even, it's not doing anything. So let the computer do the thing the computer excels at. And leave the nonsense to humans. Right, I'm just testing these edges. I kind of expected at least one of them to have a thing, but it is now time to do the thinkable. It is time to use a breakpoint and run it in the debugger. Oh boy. Let's make some room transitions so we have no idea where we are. Bang, we set that one. Yeah, the trace line's fine. Bang, we're going to set... Oh no! How did I do that thing? Debugger log. Reload debugger couple. Do I have to do that every time? Well, whatever. Okay, well that's cool. I thought it would have done that like at startup, but apparently not. Cool. So room basis is going to be something. Room pause is that. Voxel pause. 21, 13, 31, right on the edge. X border, Y border false, Z border true. We got a Z border. Okay. And we can set this because it's only one border. Setting it clearly works. If we're not recascading, then we return, but we are. Set that axis to 100 apparently. That should be false, that should be false, 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 false. That should be true. It is. So we're going to move this CF to a different reference frame. And we're going to set voxel cascade. No, I didn't do it right. Whoops. Okay, I realized what I should have I should put the breakpoint here. Okay, let's just check we have indeed once more got a... No, this one's not even on the edge. Oh yeah, that's right, next to the edge. Bang, that one's definitely on the edge. Voxel pause, 31, just like the doctor ordered. Set voxel cascade, boom. No, I don't really want to... Oh, I managed to do it anyway. Turn that down. Okay, this time, if you recall, it was going to go to the negative W room, watermelons. So RF should be negative. Huh! Whoa, well that's a pretty serious bug. It's not got the right reference frame at all. I reacted because I looked at the reference frame expecting it to see negative W and it said positive X. So goodness knows where it was setting a thing. Let's just try running it from there. Oh, that just crashed. Okay, we'll debug it then. Why did you just crash, you silly, silly machine? Boom. Cool, let's cascade it down. So this should be negative W. Yeah, cool. And the voxel pause here is... Why does the debugger... Use debugging helpers? Absolutely. But why wouldn't that always load? I don't understand. I don't understand. Wow, voxel pause 21016. Yeah, that's believable. Yep. Yep. It worked. It worked. Oh, did I do a trace line across rooms? Oh, there we go. It works on that one specific example, and that one, and that one, and that one. Wow, my gosh, and that one. But not that one. How did that happen? Oh yeah, because this does really stupid things. It never properly bounds checks. Ah. Okay, so if you click and it trace lines outside the room, then it has a really bad time about it. But that's fine. All we need to do is not do that. Actually, all we need to do is make sure the trace line works. Let's try a little experiment. Oh, look at that. Oh, nice. So apart from the fact that this all looks like garbage, that's now nice and consistent. And it might even work with hypercuboids, but I have no idea because that stuff, I really stretched my grey matter and had virtually no confidence that what I implemented was even close to correct. But who cares? When the day in the far future comes when I want to do hypercuboids, I'll probably look at that code and still be just as confused as I am now. So it's not like I lost anything. Also, I might just never do cuboids. But it would be really cool, right? It would be pretty cool. You could have like a really long one. Like you could have 2 cube cells with like a bunch of really long tunnels connecting them. So that's nice. You could do some stuff that's cool. This trace line, I wanted to get this done today and it's so late now because I spent forever writing a set voxel function because it was confusing and hard because making a 4D game isn't the easiest thing in the world. But you know, chill out, it's cool. I just want to get this somewhere at some point. I don't want endless streams where I'm just working on the same thing. So I guess I could stick with it, do another 10 minutes, try and get the, as if it's going to be done in 10 minutes, get the trace lines working across rooms and structured in a way that terminates a bit more sensibly. Implement set get voxel functions. What did I type in? Git push. I'm still on my traceline branch. I just started a branch. I'm going to merge it back when the trace lines are done. So then master will always be full of purity and joy. So I guess it's kind of the same thing on the trace line to an extent. Initial bounds check. This is something tricky. So you want to check if you exceed the bounds of the room you're in. If you go outside the room, you want to move to the next room. But as you do that, oh my god, I'm going to have to do that thing again. No, I will never do the thing. No, so if you're going out of bounds on this, you want to store your t value. I'm going to be daring. I'm going to change that to traceline room and make a new traceline function. Also, I don't... trace, pause, no, end. I want that to be the end point. And the normal. I guess, can I do initializers for them? No, I don't want to build. This is obviously going to break everything. Okay. Now, let's say I want to trace line room in the world using that result thing, which encapsulates a couple pieces of this with that pause in line. And now the start position is not room pause. Is room pause actually used after this? No, it's not. So room pause is not the start position, but it is the position in the room coordinates. Start is room pause plus trace t times room line. Now if you're way out of the thing, then that will get you close to it. Everything else is cool. So now you're trundling along. It's a very fractional part of start. It's start minus room pause. Is it? Let's have far to the next cell. I'm getting lost in this again. Jeez, why is programming hard? It's probably because I'm making a really overly complex game. Okay, I think I need to add trace t on here. So initial bounce check, let's just skip that for now. While true is a terrible way of doing anything, but that's what we're doing. T is going to go because that is not a thing. Result T and RF are already set. We don't need a trace result, it's just trace. There we go. We don't need to return it because it's input. But what we do want to return is, what do we want to return? So in this case we want to say, hey, move on this axis. In this case we want to be like, hey, it's cool. And in this case it's also cool. Like both of these are like, yeah, trace is done. So let's just return a bool. Is the trace complete? Yes. Cool, we're good. These are both good. This is going to be so confusing for cuboids. I really need a better solution for what to do for cuboids, and my current idea is just to stop trying to do cuboids, but I really want them kind of just... I feel like they'd be really cool. You know, why not, eh? Also, if I don't do them, people will be like, hey, why don't you do cuboids? They didn't see this struggle. They don't know what I've been through. Okay. Yeah, I definitely need a better solution for cuboids to do with adjusting or quickly getting the size of the dimension of the room in a specific reference frame. And it's probably not even complicated. It's probably just like you multiply something together and dot it with the size or something. The problem is it's not intuitively obvious, so I'm going to have to scribble a lot until I figure it out, and then I'll just be like, easy. Like all that stuff with the transposing matrices and orthonormal bases and like combining 3D to 4D matrices. Yeah, it's totally easy, but that's because I worked that out years ago and then just kind of knew that it worked. But working that out was just, honestly, like, I think 3 weeks I was just stuck trying to figure out how to rotate stuff, and I had all these complex algorithms, so it's just like, hey, well, if it's this and that, then do something else, and it's sort of, you know, intuitively that that's wrong, but the end solution is just, hey, turn things into matrices and then transpose and multiply them, and it is super elegant, which is worse because then you're like, okay, there's super elegant solutions for things out there. Does everything have a super elegant solution? Maybe. Maybe. But okay, for anyway, the concept here is quite simple. I'm just going to get a push direction. I'm going to pass that in, trace x is push direction. This is quite a bulky bit of code. Push is opposite of the normal, I believe. False. Okay, cool. Now we know we're going to push in that direction. Presumably. Okay, we did it, and then we need to just adjust, pause, based on that move. See, this is where the hypercuboid stuff is really kicking my butt. So the missing piece here is this pause. We've traced the line through one room and it's going to the next room, so we kind of just move to that room. we don't want to start the line again at the same position. The line started in the previous room, so its coordinates should be further out and it should be coming in. And how do you do that? Well, if it's depending on how you move from one state to another, you're either adding or subtracting a room width, height, or depth from somewhere. And if this code is anything to go by, it's not super clear to me what you're doing, but hopefully I can come up with a way, because like twice in one stream I've got stuck thinking about how do you know what's the size of the room that you moved through. And it comes up like here as well. It just say, hey, it's 32. And I think there's one other place where it just says, oh, it's 32. Which I remember in the previous stream I was like, well, if I get rid of them, I can do it. I think it was... yeah, this stuff. This also just assumes the room is 32 units. So any transition between one room and another causes a change of 32 units in your coordinates, which is terrible because it's not even like a variable. So I couldn't have different size hypercubes, which I kind of would like. It might be nice to have like a level where it's just like a massive one, this gigantic, or this really tiny one. Or maybe like a hypercuboid would be so fun because you could have one where it's just got like, it's like got one room that's too small for you to fit in, but you can pass through it by turning yourself into another reference frame, fitting through it, and then, you know, there's definitely fun to be had with sizes. And all I think I've done this stream is identify a severe weakness in my knowledge of how to do this effectively. Adjust position by room size here. I feel like maybe there could be some function that takes a position in a reference frame and permutes the whole thing. Would that work for the rendering engine? Probably, yeah. But at the same time, I don't want it to be too tied together into a concept of moving a position through a reference frame. Because I can just move a reference frame and say, hey, this is a reference frame. If I move that direction, what would the next reference frame be? That's cool. But like, say I had 50 points, like, I wanted to like adjust, like I had a particle effect between two rooms. I wanted to adjust the points in different ways. I want to adjust the reference. I know what both the reference frames are. I don't really care. I just would like a way of adjusting positions quickly and elegantly and with a very rational API. So it's not like I'm asking too much. Anyway, having identified a gap in my knowledge, I feel it's probably good to stop here rather than just smashing my face against a wall for another half hour. And I'll scribble it out on paper and see if I can come up with something really nice for the next stream, where I'll just be like, oh yes, this is easy. Who would ever get stuck on this thing? Yeah, that's the idea. Alright, it's been good chilling. No one's watching. Alright, later. Oh, can I raid someone? No. Wait, it's just, there's no one watching. Why am I trying to raid? Right, I'm gonna click stop now. Bye.